Enterprise Management 360, your main source for tech news, analysis, podcasts, and videos for the enterprise.
Hi, everyone. Welcome to the EM360 Podcast, where we have a weekly conversation with innovators that are shaping the enterprise technology landscape. I'm your host today, Kevin Petrie, VP of Research at BARC, which is a global research and consulting firm focused on data, analytics, and of course, artificial intelligence. As we all know, the tech world is on fire right now with generative AI, an emerging technology that creates content, text, imagery, audio, even video, based on what it learns about similar content and based on natural language prompts from human beings. The speed, sophistication, and the range of Gen AI language models and the use cases they address, most notably, of course, ChatGPT from OpenAI, but others including Gemini from Google and so forth, has the potential to make humans a lot more productive, companies more innovative, and life more rewarding. The big catch, and it's a big catch, of course, is that Gen AI language models are only as good as their inputs. Companies need to train and prompt these language models with trustworthy inputs. So that brings us to today's topic, which is managing the vectors that encapsulate inputs for Gen AI. We're going to examine approaches for storing, organizing, searching, and delivering vectorized content to language models. We'll also explore how to optimize all your structured and unstructured content to support a range of AI applications, from Gen AI to predictive ML to recommendation engines. Spoiler alert, you need more than just a vector database. So it's a meaty topic, and to do it justice, I'm joined today by Jon Bratseth, CEO of Vespa.ai. Jon is a serial entrepreneur and longtime architect at companies such as Yahoo and Verizon. Just last year, Jon founded Vespa.ai, provider of a vector database and more. Jon, thanks for joining us. To start, perhaps you can tell us what prompted you to start Vespa.ai.
Well, Vespa is a platform that we have been developing for a very long time inside Yahoo. Actually, we started it as a web search engine back in the early 2000s and then were acquired by Yahoo, where we built it out to a much more general platform, both for text, vectors, as well as structured data, because most problems really, as we get back to, have elements of all of this, right? So we did that inside Yahoo, but then we saw that the potential of this platform was applicable way beyond Yahoo, right? So we were working for a long time actually on spinning it back out of Yahoo. And finally, last year we were able to complete that spin out.
So that's interesting. So you've been through a few innovation waves and generations of innovation when it relates to searching text, interacting with text, and so forth. So that gives you, I think, a good background for understanding and maybe putting into context the current hype and excitement around Gen AI, because it didn't suddenly poof onto the landscape. Rather, it's the result of a lot of innovation over time. So, Jon, maybe we could start with some quick definitions. What is a vector, and how does it support Gen AI language models?
Yeah, a vector, just very concretely and physically, is just a list of numbers, right? But this list of numbers actually somehow abstractly gives you a location in an abstract semantic space. And that allows you to do reasoning on a semantic level. Specifically, you can find stuff that is similar in this vector space, in the semantic space, which is very useful if you, for example, as we talk about here, need to retrieve text, but what you're talking about when you want to retrieve it may be using a different vocabulary than the information you're looking for. But since you're retrieving in a semantic space, you can still find that information, which is very useful.
So if we were to put this in terms of an example, if we think of the Declaration of Independence or the Gettysburg Address, and we were to divide it into chunks and convert all the words to tokens, the vectors could capture the numbers that are going to describe these different chunks, these different words, and how they relate to one another in an attention network. Is that a fair summary?
Yeah, and I think that's a good. I haven't read that declaration, but I imagine that the guys, I imagine the guys back then were using a slightly different vocabulary than we would typically use today. So that's a good example, right? You would be looking for something specific, but you wouldn't find it because you wouldn't use their 17th century words or whatever. But the models that are producing those vectors, they know about all these different words that really describe the same concepts. So you will be able to find them in the vector space.
So the vectors are going to numerically capture the nuances of how Benjamin Franklin and John Adams and Thomas Jefferson were using language 250 years ago. And they're going to understand the nuances, which would be distinct, obviously, from the way that people use language on X or Twitter today. Good. Okay. Okay. So now let's talk about the types of data platforms that Gen AI initiatives require. There's so much excitement, as we know right now, about artificial intelligence, about generative AI as sort of the tip of the spear, as a way for humans to interact with machines in new and kind of stunning ways. But as a longtime data guy, I'm passionate about the notion that you need to feed accurate inputs. You need high quality, accurate data, accurate vectors to support all that. So perhaps you could talk about the type of data platform that's required to support generative AI as part of a larger initiative.
Yes. So the sort of table stakes functionality you need is really two things, right? You need to be able to produce these vector embeddings from a large language model. That's really the easy part, expensive, but easy. You either call OpenAI or some other API and have them return a vector for you for some piece of text, or you can run your own model, typically on a GPU, to do the same thing locally. So once you have that, you have the vectors. And what you want to do with those vectors really is to put them somewhere so that in the future, when you have some text that you produce a vector for, you can find vectors and therefore text that is similar to that vector. So you need similarity search. The dumb way to do this is to just look at all the vectors you have and compute the distance to your given vector, brute force, right? This is what we used to do back 10 years ago when we did this kind of thing typically for ad targeting systems, as well as recommendation systems and so on, that typically have smaller content pools where this makes economic sense, right? The innovation that we got about 7 years ago now is efficient ways to index these vectors so that we can find similar vectors much, much faster than comparing to all the vectors. So that's the innovation that we had back then, which is now becoming table stakes. You had vector databases that were doing only these things, but gradually now all the other databases are really adding this functionality. So I imagine that a few years down the line, everybody will have this.
So this is interesting. So yeah, we have text, we're converting it to vectors, which numerically capture the meaning, the semantic interrelationships of text, and this can apply to imagery and audio clips and so forth, as we said. So now it's in the vector database, and the vector database needs to store that. It needs to be able to search it, doing a similarity search, and then retrieve it very quickly in order to provide the right inputs to language models. And what we've seen is that there are two primary technical use cases for that. One is that the vector database can help companies fine-tune, which means perform another level of training on pre-trained language models. They can help companies provide the right inputs so that you can have, in our earlier example, a language model that understands the nuances of how the Declaration of Independence uses language versus today. So there's assisting with fine-tuning, and then there's retrieval-augmented generation, which gets a lot of attention, which is referring to pulling up through a similarity search the most relevant content for a given user prompt and feeding that into the prompt itself so that the language model has, in a sense, an open book test and can answer a given human question more accurately. Perhaps you could comment, are those the two of the use cases that, in the context of generative AI, Vespa is supporting? Is it more retrieval augmented generation than fine tuning?
Yeah, I know some customers that actually use Vespa for fine tuning, but it's typically an offline process, and you can really use whatever is most convenient for you. And the other thing is, most people don't actually fine tune. It's not popular to do at all. Yeah, it's a lot of work. I think you get better results, but if you do a good job with prompting, you can sort of almost get there. So my impression is that most people vastly prefer that, at least so far. So yeah, what we focus mostly is the RAG use cases, right? Because you need scale, you need accuracy, and you need low latency, and those are our specialities.
Okay, maybe you could talk about, beyond generative AI, how your platform is helping recommendation engines, other types of machine learning models, handling high dimension data that has a lot of features to it.
Yeah, when you think about it, the thing you're using vectors for that is useful, right? Which is finding stuff in a semantic space rather than require exact text match, as well as being able to find images and audio clips and so on. That's not just useful to these large language models to prompt them better, right? It's also very useful for humans, obviously, right? So we see a lot of use cases along those lines. For example, if you go to Spotify and try to find some podcast like this, and you don't really know the words that are put in the description about that podcast, right? But you can describe in your words what you're really looking for, right? That's a similar problem. And there, you will actually hit Vespa and do a similarity search in a vector space and retrieve podcasts that are maybe useful to you, but as we'll get back to, it's just maybe. The vectors don't really solve that problem perfectly for you. So what we're doing in the second stage is to feed all the information about those candidate podcasts into another smaller neural net, much smaller than the ones used in these large language models, that can tell us if the podcast really is good for what the user is asking about and a description of the user, and then return that. So there's lots of use cases like this where you either support search for humans or recommendation, which is kind of the same thing. It's just that you don't have a textual query. You just have the information about what's going on and who this person is that needs something. And there you have the same problem, basically, that you want to surface information that as well as possible, where vector is really helpful.
Excellent. So with our research at BARC, and previously I was with Eckerson Group, and what we found is that there are three stages, somewhat sequential, with Gen AI adoption. The first one is that ChatGPT burst onto the scene in November 2022, and a lot of knowledge workers and consumers started using language models, especially that one, to experiment, but also to improve their productivity. And that was great. Stage two is using language models that are features within productivity tools like Salesforce Einstein or like GitHub Copilot. And so that can further improve productivity. What's interesting now is that we're in a stage three, which is companies applying Gen AI language models to their own domain specific data. in order to not just improve productivity, but also gain competitive advantage. And that's where I think companies like Vespa become particularly interesting, helping companies go beyond what is just available off the shelf and prompting or potentially fine-tuning those models with their own data. What if you look at the most innovative users in that third camp right now? What are the best practices? What are they doing right? And what are some pitfalls?
Yeah, excellent question. That's exactly what we see, that most of the customers we help are in that space, large enterprises that wants to apply this new technology on their own data. What we typically see is that vectors are really not enough, right? It allows you to come up with a compelling demo that you can show on Twitter or to your CTO, but once you want to go beyond that and have something that is solid in production, you need a lot more. First off, you need to incorporate your structured metadata that you have about whatever is your subject matter. You typically only just don't have the text, right? You have additional information, how old is this, how authoritative is it, who has access to it, all of these things, right? And that's structured data that you also need to take into account. You need to take them into account in two ways. You need to filter out the stuff that is not really relevant to the task at hand. And you need to feed those signals as with the vector into a final, smaller machine learning model, like in the Spotify example, that will look at all this information and make the final determination whether this is something you should surface for this particular situation or not. Right? So that's one thing. The other thing is vectors are great because they allow you to find stuff in the semantic similarity space rather than using precisional words, right? But when you're doing that, you also lose that precision, right? You're sort of squinting on the text and, this is sort of like the same thing as this other thing, and therefore we should return it. That has two problems, right? You will retrieve stuff that is not really similar enough, so you should ignore it. And therefore you will miss a lot of things that uses the exact same words that you're looking for, but are not really viewed as a sort of coarse approximate vector, is not really showing up highly enough. For example, if you're dealing with addresses, right? Unless it's some world famous address like Wall Street or something, the large language model won't know about your specific address at all. So the vector will just say abstractly, this is an address, right? But if you're looking for a particular address, that is not very helpful, right? So in those cases, you need a precise lexical match of the actual words that are in the text. So to solve those kind of use cases, and there are a lot of those in enterprise use cases, right? It could be the shelf your some kind of stock is on, or the exact internal code name for a project, anything like that. The language model hasn't seen it, or if it has seen it, is just doesn't show off enough that it will actually learn something useful about it, right? So you need the vectors, but you also need to index the actual text and do old school text matching, and then use both sources of information and feed both of it into this final machine learning model that will do the final determination. So it needs to look at both the vectors and the text match degree, as well as this structured metadata, and then make a determination based on all of that. Then you get the quality you need to put something in production in an enterprise.
Very interesting. And it's nice to hear, because I have been making similar points. There's this tendency to look at generative AI as an island unto itself, but it's really part of a multifaceted initiative. And it underscores, I think, a need for companies to focus on fundamentals like master data management so that they're using consistent names for customers in their unstructured text. Tables still seem to matter. If you're talking to a customer, you want to make sure you have the precise number related to a recent transaction or a recent purchase. So there are a lot of cases in which tables matter, data quality matters, and master data management matters, and all that starts to feed into these multifaceted inputs to multifaceted applications. And it sounds like you're helping address the use of, as you said, both text and vectors, and then the metadata as well. Perhaps you could talk a little bit more about metadata and best practices for companies to handle that and curate metadata that really captures how those inputs should be used.
Yeah, a little bit. We are not really. So Vespa is kind of at the end of your kitchen where you cook up these solutions in a way, right? There's lots going on creating features, curating your data, and so on. That's typically happen offline in your data lake or data warehouse or whatever. While Vespa is the final recipient of that data that you actually want to apply in an online setting where you're dealing directly with consumers or with your customer support personnel or something like that. So we are not really experts on how you get there, which is another big topic. But yeah, the better data quality you have, the better your results. The large language models won't really get you out of that situation. It's fundamental.
What are the most common customer problems that you're solving, and how does Vespa differentiate itself in the market? There are a number of vector database companies. I know that you're addressing a broader range of problems, but perhaps you could help us understand your target use cases and target problems and how you differentiate yourself there.
Yes, these vector databases are geared towards only receiving vectors and then returning vectors by similarity. That's the core thing they are doing, right? What we have seen with Vespa over the years, and which I spoke about now, is that you need to look at both vectors, metadata, as well as text. And then once you have more than one thing you're looking at, then you need to combine multiple signals. And how do you combine multiple signals to make a decision? You use machine learning, right? So you also need the machine learned inference that goes with this solution. And because you're doing this for many candidate data items for every single query, and you have a lot of queries, scalability becomes a big issue, right? So what you really need is one platform that organizes the data and the compute, specifically running this machine learned inference where you store the data. You need a platform that does all of that, and Vespa is that platform. These other vector databases are not really even trying to solve this problem that we believe is fundamental.
Okay. Well, Jon, this has been very educational. I appreciate you making me a little smarter on this topic, and our listeners as well. Thank you to everyone for listening. We hope you took a lot away from today's podcast. For further information on all this, you can head over to Vespa.ai. They've got some rich content about the technical problems that companies need to solve in this area. And I thought a pretty good, meaty page on use cases and the right steps to take to address those. So, Jon, thanks again.
Thanks for having me, Kevin.
Okay. So we'll be back next week with another episode in our podcast series. Until then, you can make sure you subscribe to this podcast on all major platforms and follow the conversation on social at EM360 Tech on X and LinkedIn. And for more great daily content, you can head over to em360tech.com.